Welcome friends to the e-learning platform, an initiative by Science Park, Savitribai Phule, Pune University. Let's start first part of our video whose topic is materials that we use for standard 7, and here I'll be covering chapter 15 from SSC board and chapter 3 from CBSE board. Subtopics for today's video we'll see toothpaste, because that is the thing that we use first we get up in the morning, in which we'll see some ancient substances used to clean teeth, to clean our teeth in India. That is acacia rigidula, म्हणजे बाभळीचं झाड सगळ्यांना माहिती असेल. And second we'll see importance of charcoal, कोळसा, जो आपल्याकडे पूर्वीपासून वापरला जातो. And second material that we use is cement. So in this video we'll talk about how cement is made, and I'll explain the process of manufacturing of cement, and finally we'll speak about uses of cement. Nowadays we all use Colgate, right? And they really advertise a lot about charcoal in Colgate or charcoal in toothpaste, which cleans your teeth. But do you know, from like 100 to 1200 years back, Indians have been using acacia bark. It's a very common tree in India. In Marathi we call it as babri. And we use the bark of that to clean our teeth. We also use charcoal tooth powder. We used to mix charcoal, which used to be homemade, and in which we used to add rock salt or saindhav salt, which is very medicinal and ayurvedic. And then nowadays we also have our own products where we use ingredients like babula, neem, bakula, then tumburu, payafala. So all these are tree extracts: pimpri, lavanga, black salt, rock salt, sphatik bhasma, karpur, that is camphor, but it is naturally made camphor, and peppermint. And still certain people who believes in Ayurveda use dantamanjans instead of using toothpaste. Now let's see about this tree, Acacia rigidula, called as babri. Each part of this plant has different benefits. Some of them are listed below. The stem bark is used, this bark is used as an astringent and also to treat various conditions such as skin diseases, hemorrhoids, cough and asthma. Now it is used especially for gums as analgesic in case of oral cavity lesions. Now charcoal, let's see about charcoal. So activated charcoal in toothpaste may help to remove surface stains on your teeth. Charcoal is mildly abrasive and is also able to absorb surface stains to some degree. Okay, it has a natural whitening effect on teeth. At the history of toothpaste, other than India, the history says that Egyptians created the most ancient form of toothpaste. Greeks, Romans, Chinese and Indians were also known to have used toothpaste in ancient times. In past, toothpaste was used to freshen breath, clean gums and whiten teeth, similar to how we use it today. However, the ingredients used to make toothpaste before were much different. Crushed bones, oyster shells and eggshells combined with pumic and the powder of ox hooves. What is ox hooves? These are ox hoof. One is of ox hoof and many are hooves. Were some of the common elements used in the western part of the world for making toothpaste. In the East, the Chinese used herbs and spices as their toothpaste. In the late 18th century, the development of toothpaste became more advanced. During this period, toothpaste was made from soap, And then in the succeeding years, chalk, betel nut and ground charcoal were added to create toothpaste. Now let's see some very important ingredients of toothpaste. First is abrasive. We need a very strengthened material to abrase the surface, the dirty surface of teeth, where we use solid and insoluble particles which can cause abrasion and remove the debris, that is dirt or residual stain from teeth. So for abrasives, nowadays we use aluminum oxide, calcium pyrophosphate or carbonates like sodium bicarbonate, calcium carbonate. Calcium carbonate is the most common material as abrasive. Nowadays people started using charcoal as abrasive, and which is the ancient abrasive used in India. We need 2% of binder in a toothpaste which can provide consistency and shape. So for binders we use polymers like carboxymethyl cellulose, alginate, etc. And third very important ingredient is humectants. 20 to 40% of humectants are used in toothpaste to prevent loss of water and subsequent hardening of the product upon exposure to air. So for humectants we use glycerin or sorbitol or some glycols. Other than this, we use certain sweeteners and flavors to improve the taste of the toothpaste. So we use sodium saccharine, sorbitol, mannitol or peppermint flavors as sweeteners. We use certain surfactants which can produce foam and aid to the removal of debris. So we use sodium lauryl sulfate or sodium N-lauryl polyethylene glycol as surfactants in the toothpaste. And very important is fluoride actives, which increases resistance to enamel solubility. Enamel is the outer covering of tooth. So we use sodium fluoride, sodium monofluorophosphates or stannous fluoride for fluoride actives. And lastly, we use certain preservatives which can prevent the growth of microorganisms on the surface of tooth. So for preservatives we use alcohols or sodium benzoate substance. Now how do teeth decay? Do you know about it? Tooth decay begins when the outer surface of the tooth is attacked by acid. The acid is produced by bacteria which live on the surfaces of the teeth as a layer called plaque. When foods or drinks containing sugars enter the mouth, the bacteria within the plaque rapidly converts the sugars into acid. The plaque can hold the acid in contact with tooth surface for up to 2 hours before it is neutralized by saliva. During the time that the plaque is acidic, some of the calcium and phosphate minerals of which enamel is largely composed of get dissolved out of the enamel into the plaque. This process is called as demineralization. Now anti-caries agents, which are mainly fluorides. So fluorides are considered to be most effective caries inhibiting agents, and almost all toothpastes today contain fluoride in one form or the other. The most common form is sodium fluoride. Here I have given you the formula for sodium fluoride. But monofluorophosphate and stannous fluoride can also be used for fluoride substitute. Fluoride is most beneficial when the mouth is not rinsed with water after toothbrushing. In this way, a bigger amount of fluoride is retained in the oral cavity. Now let's see production of cement, which is a major part of our society. Cement has an average additive content of 23%. These additives were of natural origin, such as limestone, volcanic rock, or industrial origin. For example, blast furnace slag, that is the steel industry byproduct, or fly ash from coal-fired power plants. The use of additives, they enhances certain cement properties, recycles materials that would otherwise have sent to landfill. Additives are used to reduce the consumption of natural raw materials, and they also reduce CO2 emission, carbon dioxide emission. A cement is a binder, right? So we use cement for whenever there is construction going on. It is a substance that sets and hardens and can bind other materials together. The word cement can be traced back to the Roman term opus cementitium, used to describe masonry resembling modern concrete that was made from crushed rock with burnt lime as binder. See how people discovered certain materials. The volcanic ash and pulverized brick supplements that were added to the burnt lime to obtain hydraulic binder were later referred as cementum, then cementum, then cement, and then finally we see it as cement, right? Cements used in construction can be characterized as being either hydraulic or non-hydraulic, depending upon the ability of the cement to set in the presence of water. So ऐसे cement के there are two types of cements, hydraulic and non-hydraulic. So it depends on how the cement sets or hardens in presence of water. Now let's see production of Portland cement, one type of cement, where the raw materials that we use for production of cement is limestone, naturally occurring stone, and calcite. Quarrying process is done, then crushing of these materials is done. Crushed limestone plus this clay shell are then mixed and ground together. Then this mixture is heated in a kiln, and then in the kilner gypsum is added and the mixture is ground to a powder, resulting in Portland cement. Now let's see the certain steps, important steps in process of production of cement. First is extraction of raw material. The raw material needed to produce cement, mainly we need calcium carbonate, silica, alumina and iron ore. They are generally extracted from limestone rock, chalk, clay shields or clay. Suitable reservoirs can be found in most of those countries for extraction of these raw materials. These raw materials are extracted from the quarry by blasting. They are then crushed and transported to the plant where they are stored and homogenized. Step 2 is raw grinding and burning. Very fine grinding processes and fine powder, which is known as a raw meal, and then it is preheated and then sent to a kiln. The material is then heated to at around 1500 degrees Celsius before being suddenly and dramatically cooled by bursts of air. This process, clinker, the basic material required for production of cements. So clinker is the intermediate product which is formed after mixing and heating and sudden cooling. Then cement manufacturing is a source of 5% of global carbon dioxide emission. The cement industry is a natural producer of carbon dioxide. 60% of emissions are due to transformation of raw material at high temperature. This process, which produces 60% of emission of carbon dioxide, is called as decarbonation of limestone. 40% result from combustion required to heat the cement kilns. Third step is cement grinding and chipping. Small amount of gypsum, about 3 to 5%, is added to the clinker to regulate how the cement will set. The mixture is then very finely ground and we obtain pure cement. During this phase, different mineral materials called cement additives may be added along with gypsum. Used in various proportions, these additives, which are of natural or industrial origin, give the cement specific properties such as reduced permeability, greater resistance to sulfates and aggressive environments, improved workability, higher quality finishes, etc. Finally, cement is stored in silos before being shipped in bulk or in bags to the sites where it will be used. Now here I have shown you the diagram, industrial diagram, how these processes that we discussed right now are done here. Now let's see some industrial uses of cement. Cement is a very useful binding material in construction, building constructions. The application of cement over various fields of construction have made it a very important civil engineering material. Some of the numerous functions of cement are: it is used in mortar for plastering, masonry work, pointing, etc. It is also used for making joints for drains and pipes. It is also used for water tightness of structure. It is used in concrete for laying floors, roofs and constructing lintels, beams, stairs. So it concludes that in past we used sand, rocks and other material to build houses, but nowadays we build our houses with cement. Cement production is very important for us. A good cement means a good house. That is it for today. Bye bye.